So in this video, we are going to see about circles in geometry. Let's get started. So we start with the circle basics. So there are three things which are represented here: chord, a diameter, a radius. So start with a circle. In a circle, all points are equidistant from central point in a plane. So this is in a plane, and all the points which lie on the circle, they are equidistant from the center. Radius is the distance from the center of the circle to any point on the circle, which means on the edge of the circle. So this would be a radius. From here to here is a radius. From here to here is a radius. If I draw another straight segment from center to here, it's also a radius. And what is this? This is a chord. What is chord? A line segment which connects two points on a circle. If this line segment, if the chord passes through the center, that chord is also called diameter. Okay, the chord which passes through the center, the line segment which touches two sides of the circle and passes through the center is called diameter. And diameter is two times the radius. So from here to here is radius and here to here is radius. So diameter is two times the radius. Again, the same thing which I told you earlier, they are being repeated here. D, which is diameter, is two times the radius. What is radius of a circle? If the diameter is 16 feet, it would be 8 feet because 16 divided by 2 is 8. Now there are two important concepts which come. Till now when we were discussing about radius, diameter, they were all line segments. And if you know line segments are bounded. So they have beginning and end. So this is a bounded because it has a beginning and end. A, B is a line segment. And here what we are saying, it's a line. So a secant is a line which touches the circle at 2 points. That is a secant. So if I say from here to here, if I say it as CD, from C to D is a chord. If I say CD, CD is a chord. But if I say this entire line which touches the circle at 2 points, it's secant. Okay, so chord and secant are very uh, relatable. Okay, chord when it becomes a line instead of a line segment is a secant. And what is tangent? Tangent is a line which touches the circle at one and only one point, and that point is called point of tangency. Okay, so line that intersects the circle twice is a secant. Tangent line that intersects a circle once. Now there are few questions which are there. What is AG? AG is a chord. Okay, because it's a if it was like this, AG as a line, okay, line has two arrows both sides. If it was a line, then it was a secant, but AG as a segment would be a chord. But it's all related. What describes the word CB? What is CB? Correct. CB is radius. Name a tangent and a secant. So AG line segment is a and DE line is tangent, yes. And one important thing to note is that if you draw a radius, okay, from the center to the point of tangency, it always has 90 degree on the tangent. On the point of tangency, if you draw a radius, this radius and this tangent will form right angle, 90 degree angle they will form. Now two circle can intersect at 2 points. Okay, they can also intersect at one point if one circle is inside another circle, and they can be one circle and second circle, they both can be concentric circles, meaning they have the same center. If they have the same center, they will and different radius. If they have same center but different radius, they are concentric circles and they never intersect with each other. So this circle is in these two circles are intersecting at 2 points. These two circles are intersecting at one point. Concentric circle intersect at no points. They have the same center but different radius. So these are the various tangents which are possible in two circles. So here this tangents, here these two tangents are shown, and here one tangent is shown like this. Okay, so these are the tangents which are possible in the two circles. Now this question, that how many tangents can this can have in common? How many tangents are possible for these two circles? Common tangents. Two common tangents are possible. So one tangent would be like this, another would be like this. Ignore, please, forgive my drawing. But two common tangents are possible. Maximum two tangents are possible, common tangents are possible in this two circles. Now let's see another example. Here, how many common tangents are possible? Yes, here only one common tangent is possible like this. Okay, like this. Only one common tangent. This ignore my drawing, but only one common tangent is possible here. In this one, how many tangents are possible? This one. Here, zero tangents are possible because they are concentric circles with different radius, so they don't have any common tangents. So tangents line are perpendicular to the radius. Okay, so if you have a tangent, if you draw a radius to the point of tangency, that would be at 90-degree angle. Another important property of tangent is tangent segments from the same point are congruent. So if you have a point from any point outside a circle, you can have maximum of two tangents. From this point, any point, maximum two tangents are possible from any external point. So for example, here from S, there are two tangents which are drawn, SR and ST, and they are both congruent. What does it mean? It means that SR, if you take the length of SR, that would be equal to the length of ST. Okay. If you take another point and draw one tangent here, again, sorry for the bad drawing, but let's say this tangent is like this and another tangent is like this. Then from here to here, let's say XY shall be same as XZ. Okay. Because tangent segments from the same point are congruent. Now the question, this is a very important question. Tell me whether DE is tangent to OC or not. Sorry, tangent to circle with center C. So this is circle with center C. Okay. This is what is written, center with circle, circle with center C. Is DE tangent or not? So you have to tell me whether DE is tangent or not. So what you have to do here is you have to use Pythagoras theorem. So what they have given is from this point, let's call this point as CDE, let's call it F. For F to E, this is 2 centimeter. Okay, 2 units. From FE is 2 units. CF would be how much? CF will be 3 because it's the radius. Radius is always same. So CF will be 3. Okay. So if you say CE is 5, total 5. If it is a tangent, if you have to prove this is a tangent, you can prove by Pythagoras theorem. If it is 90-degree, then it is a tangent. So 3 square plus 4 square, 9 plus 4 is how much? 25. So if you find the hypotenuse from Pythagoras theorem will be h equal to square root of 25, which will be equal to 5, and here the hypotenuse is 5, so 3 plus 2 5, so which means this line is tangent to DE is tangent to the circle with center C. Okay, so this is another question. So second question, ST is a tangent to a circle with center Q. So ST is what? It's a tangent. Find the value of R. So in this question, what you have to do is you have to apply the Pythagorean theorem one more time. So r square plus 24 square. So r square plus 24 square would be equals to plus 18 square. R plus 18 square. Because r plus 18 is the hypotenuse. We learned already that the radius on the point of tangency makes a 90-degree angle. So r square plus 24 square equal to r plus 18 square. And when you solve this equation, you will find the value of r, and you know that r would be positive. So you would ignore the negative value and r would be positive. So in this equation, you have to find the value of x. What would be the value of x? The value of x would be 3 because these two are tangents. Why they are tangents? Because they are forming 90-degree. And tangents from the same point are congruent. If they are congruent, that means 9 equals to x square. And when you solve x, x will be plus or minus 3. And you cannot take negative because it's a distance. So x would be 3. Okay. So x is equal to 3. Now we would learn something about arcs. Okay, what are arc in circles? So if you cut the pizza into 8 equal pieces, what do you do? So you have a pizza. It's not a circular, but consider it is a circle. So first you will divide it into half. Okay. Then you will again divide whatever parts are there. You divide it again into half. Then you divide half. So this side is equal to this side if the drawing is proper. And you divide one more half. This side with this line, this side, and this line, this side is equal. So this is a pizza which is divided into 8 parts. Now see, remember that in a circle from here to here, if you form an angle, it is a 360-degree angle. So every angle for every piece, if you take the angle of every piece, that angle of every piece, because they are cut equally, every angle will be equals to 45 degree. So there are 360 degree in a complete circle. Central angle. When you form a angle on the center of the circle, okay, from any 2 points on a circle, if you form the angle on the center, that is called a central angle. For example, here AB are 2 points on the circle and they are forming 50-degree angle, which means ACB is 50 degree. Okay, and this is what is called a arc. Any 2 points on the circle are called arc, and the measure of that arc is the angle, is the central angle they form. So for example, these 2 points are forming 50 degree. So if somebody says what is the measure of AB arc, arc is represented by arc line. Okay, this is arc line. So measure of AB is how much? 50 degree, because the central angle they form is 50 degree. An arc is a portion of a circle. The central angle cuts the circle into two arcs. So how two arcs? One arc is AB, which is also called a minor arc. Second arc is ADB. Why we have to say D? Because so that we don't confuse with AB arc. This is, if I say what is AB arc, it is this one. The minor arc is the AB arc. But if I say what is the measure of arc ADB, how much will be the measure of arc ADB? How much it will be? It will be 360 minus 50, which is 210. Why 360 minus 50? Because entirely it forms a 360 degree and 50 degrees taken by this. So ADB will be 360 minus 50, which is 310. Okay, so measure of this major arc ADB is 310. So here you have seen this is called minor arc AB and this is called major arc ADB. So this is a major arc which is indicated with the blue, and with the red the minor arc is indicated. Again the definition again. Smaller of the two arc is called the minor arc. Measure of arcs are the measure of the central angle. Bigger of the two arc is the major arc. So major arc would be 360 minus the measure of the minor arc. And this is what I was telling you before, that to identify a minor arc, you have to give only two endpoints. So here, if you say AB, then it is a minor arc. If 3 points are given, it will be a major arc because ADB. Otherwise, you will confuse with AB minor. So that's why 3 points are given, 3 letters are given to identify a major arc. Name the minor arc and its measure. What is the measure of the minor arc? What is the minor arc? So AB is the minor arc. If you see AB, that is the minor arc. And what is the measure? Measure of minor arc is the central angle. So AB is forming in the center, it is forming 135 degree. So 135, measure of AB is 135. And if you have to say measure arc, then measure arc is ADB. You have to have 3 points for the measure arc. So ADB is measure arc major arc, and its central angle would be 360 minus 135. So the question here is, can you have some major arc and minor arc, and can you find a semicircle here? Okay, so I would focus on the semicircle part first. Can you see any line which is a diameter? TR is a diameter. Why? TR is a diameter because it's a straight line. Why it is a straight line? Straight line has a property that it will form 180 degree. So 120 plus 60 is 180. So it is definitely a straight line. So TR is a radius here. And this would be how much? This will be 100. Okay, and remember these are not vertical lines because these are not vertical angles. Vertical angles require two lines to intersect, and if they are intersecting then these angles are equal. This is equal and this is equal to this one. Okay, but that is for two straight lines, but here these are not two straight lines. So this is 180, this is 180. Okay, so that's important here. uh, so this is what is identified as a minor arc. TQ is a minor arc. If you say TQR, that is a major arc. QRT is also a major arc. Any 3 points you see, if you are writing 3 points, it will be a major arc. Semicircle arc. What is a semicircle arc? If the central angle is 180 degree, then it is a semicircle arc. So diameter forms a semicircle arc. Okay. Similar circles. So you have seen triangle similarity in the past. Similarly, there is something called circle similarity. But in circle similarity, all the circles are similar. There is no circle which is not similar, which means the angle of all the central angle of all the circles is 360. If you have this circle, then you have a smaller circle. They will at the center line, they will form 360 degree only. So this is very important thing. Every circle is similar. Okay, every circle which you can form is a similar circle. If you have to say whether two circles are congruent or not, they are congruent if they have the same radius. Two circles are congruent if they have the same radius, because if they are congruent, then their perimeter, or which is called circumference, would be same, because 2 pi r would be same in both cases, and area, which is pi r square, also will be same if those two circles are congruent. Okay, this first one is the perimeter, second one is the area. Congruent arcs. So if there is a circle or more than one circle, in the circle, if the radius is same and the measure of the arc is same, they are congruent arc. So here we have to say whether these arcs are congruent or not. Yes, they are congruent. Why? Because radius is same. Here radius is same. Also, the measure of the both the arcs are same. So AB arc is congruent to CD arc. Here are they congruent? They are not congruent here because the radius of the two circles are different. So not congruent and congruent. Now we'll read about chords. We have already seen secant, and when we saw secant was a line which was touching the circle at 2 points. Okay. Chord is a line segment which touches the circle at 2 points. Okay. So when you have an arc, if you join the 2 points of the arc, that will form a chord. Okay. When you have an arc, you join. So any 2 points you take in a circle, join those 2 points. It will form what? It will form a chord. In the same circle or congruent circles, two minor arcs are congruent if their chords are congruent. So this is another property. If there are, if these two chords are congruent, let's say the length of this chord and the length of this chord is equal, okay, then the arcs are also congruent, which means if you take the central angle of this and take the central angle of this, both will be same. Okay, so if chords are congruent, then arcs are also congruent, or if the arcs are congruent, then chords are also congruent. So here tell me how much would be FG. Measure or of FG, how much would be the measure of FG, which means this one would be how much? What is the measure of JK, sorry? JK is 120 degree because central angle here is 120. Okay, that's what is indicated here for JK. And JK is congruent to GF. because the length is same and it is also given the radius is same. If you see here, this indicates the radius is same. Okay, and this is indicating that these two are congruent chords. Why they are congruent? Because in a congruent circle, if the chords are of the same length, they are congruent. So which means GF measure will also be 120 degrees. Measure of AB is 110. AB measure is 110. Find the measure of BC. How much would be the measure of BC? It will also be 110 because it is the same circle, which means AB and CD are of the same length also is given, which means these two chords are congruent, which means that the arcs which these two chords form, they will also be congruent. So both of them would be 110. If one chord is perpendicular bisector of another chord, then the first chord is a diameter. This is a very important property. What does it mean? If you draw a perpendicular bisector on a chord, if you ever draw a perpendicular bisector on a chord, you take any chord. Okay, what is a perpendicular bisector? Perpendicular bisector divides a line segment into two equal parts. So which means if TA was a chord, TA is a chord, a bisector, a perpendicular bisector will, first of all, if this point is M, then TM will be equals to MA. That is a bisector. And when we say perpendicular bisector, it forms 90-degree also. So in here, what would happen? The perpendicular bisector will always pass through the center. Okay. And this chord, whatever this chord is, if I say it is XY chord would be the diameter. So a perpendicular bisector of a chord passes through center of the circle, and it is a diameter because it passes through the center of the circle. It is a straight segment, straight line segment, so definitely it's a diameter. If a diameter is perpendicular to the chord, okay, if a diameter is perpendicular, it's a corollary of the same theorem. If a diameter is perpendicular, then this part would be equals to this part because it will be a bisector. If it is dividing, if a diameter is dividing the line segment into two equal parts, then it is a bisector. If a diameter is perpendicular to the chord, if a diameter is perpendicular to the chord, it is perpendicular to the chord, then it is, we can have another diameter. For example, another diameter will go like this. Let's say this diameter is going like this. Now what happened? This did not make a 90-degree angle, so it does not bisect. But if it was making a 90-degree angle, like in this case it is making a 90-degree angle, then FH will be equal to HD. If a diameter is perpendicular to the chord, then it bisects the chord and its arc. Okay, it bisects the arc as well. So which means that if the measure of this arc was, let's say, 110, FGD measure was, or FD measure was 110, then the measure of FG and DG will be equal, which means both of them will be 55. If F measure of FD equals to FD equals to 110, okay, then the measure of FG would be 55 and measure of DG will also be 55 because it divides into two equal parts, both the chord and the arc. Now you have to find the measure of the indicated arc. Find the measure of the indicated arc. So you have to find the measure of ADE. So how you will find the measure of the ADE? So this is very simple. So here, because it is a diameter, this is a diameter and the diameter is cutting CE into two equal parts. So this has bisected. If I call it X, then CX and EX are equal because it's a diameter cutting the chord by 90-degree, which means measure of CD and measure of DE will be equal. Okay, which means 9x degrees will be equal to 8 minus x degrees. Okay, 80 minus x degrees. And if you solve this, 10x will become 80 and x will become 8. So if it is 8, then it will be 9, 8 is 72. This will be 72. And if you see, it is 80 minus 8. This will also be 72. Okay. And if you have to say CE, CE will be 72, 72. If you add those, 144. In the same circle or congruent circle, this is congruent sign, two chords are congruent if they are equidistant from the center. So earlier we saw that two chords are congruent when their length are same. Two chords are congruent when their arcs are measure of their arcs are same. Two chords are also congruent if they are equidistant from the center, which means EF, equidistance from the center, meaning if you draw a 90-degree altitude on this line AF, which is EF, and same 90-degree on CD, which is EG, if these two are equal, EF equal to EG, this will mean that AB is congruent to CD. Also, the arc AB is congruent to arc CD. Okay, EF should be equal to EG. Now, this question they are asking to solve. So this is again very easy question similar to before question. So here it is given that HG is congruent to EF because both of them are 15. This is also 15. This is also 15. So QA will be equal to QB. So 4x plus 1 will be equal to x plus 8. Okay. So find x. So then if you solve this 4x plus 1, 4x plus 1 will be equal to 1 equal to x plus 8. Okay. And if you do 3x will be 7. If you solve this 3x will be 7 and x will be 7 by 3. Okay. X shall be 7 by 3 because these two chords are congruent. So they are equidistant from the center. Now we have to see something called as a inscribed angles. Okay. So inscribed angle, what is inscribed? What is inscribe? Okay, if you write on something, that writing is called inscribing, or you engrave it, that is also called inscribing. Okay, in circle, the inscribed angle is if you take any 2 points, it these 2 points make an angle on the circle. That angle is called a inscribed angle. So this angle is an inscribed angle, and same 2 points can form another inscribed angle on the other side of the circle. So this is the measure arc. If you have to study in a different way, let's say AB, and let's say this is C. So ACD is the measure arc, AD is the minor arc, and this is an inscribed angle. Wherever it touches on the circle, that is an inscribed angle. An angle whose vertex is on the edge of the circle. So whenever we say edge of the circle, it is the perimeter, sorry, the circumference of the circle, on the circle, which means on the circumference. So edge is like any point here in a circle is a edge. Okay. So if an angle is formed on the edge like this, any angle is formed, that is an inscribed angle. Okay. So this is an inscribed angle, this may be another inscribed angle, this may be another inscribed angle. So all these angles which are forming on the edge of the circle, they are inscribed angles. The arc of a circle that is in the angle, intercepted arc. So when you have the inscribed angle, so inscribed angle will form a arc on the circle. Okay, because when you draw the angle at any point on the circle, it will these line segments are going to meet somewhere in the circle, correct? For example, I draw these. So when I draw these two, so this part is a intercepted arc. So intercepted arc is inscribed angle when it the line segment meet at the circle. Those 2 points make a intercepted arc. So inscribed angle and intercepted arc. The arc of the circle that is in the angle. The measure of inscribed angle is half the measure of intercepted arc. This is a very important property. So intercepted arc would be what? Measure of intercepted arc is the measure of the central angle. If this is the center, then this will be the measure of this angle. Oh, sorry. Uh, if this is the center, I'll please ignore the wrong handwriting. But this angle, if this was a center, this angle is a central angle. So this central angle or the measure of the intercepted arc is half of the inscribed angle. So if this is x, then this will be 2x. The central angle would be 2x. The measure of an inscribed angle is half the measure of the intercepted arc. If two inscribed angles of the same or congruent circle intercept arc congruent arcs, then the angles are equal. So which means from AB, this is a arc AB, you can draw any inscribed angle from these 2 points. Okay, you draw this one more I am drawing here. On the same side, if you draw any number of, this is or at the edge of the circle. So any angle, any inscribed angle, if I take from 2 points of a arc, they will always be equal. Okay, so inscribed angles, which means any angle on the point, anywhere in the point, they would always be equal. And what would they be? They would be half of measure of AB. Okay, any inscribed angle would be half of the measure of that arc. If an inscribed angle of a circle intercepts a semicircle, so what has happened here? This is a inscribed angle, and this inscribed angle is formed at what? It is formed as at a diameter, because it intercepts at a semicircle. Then the angle is a right angle. Why it is right angle? Because diameter is 180 degree. If it is 180 degree, inscribed angle will be half of 180, so it will be 90 degree. Okay, so remember that if a diameter, from a diameter, you make any inscribed angle. Okay, any inscribed angle you make from a diameter, it will always be 90 degree. If a quadrilateral is inscribed in a circle, then opposite angles are supplementary. So what is the meaning of supplementary? Supplementary meaning they will be forming a 180 degree angle. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So this is an inscribed quadrilateral. Okay, any quadrilateral which you can form within a circle, then the opposite angles, this plus this, would be 180 degree. And same, this one, angle D plus angle F would also be 180 degree. They are supplementary. So angle E plus angle G is 180 degree. That is what is the meaning of supplementary. Okay, so what it is asking here is that it is asking the this inscribed angle, it is asking HGF is what it is asking. HF is 90, which means at the center it is forming a 90 degree angle, central angle, and we know the inscribed angle is half of the central angle, so this angle will be 45 degrees. This is 72. How much is this one? ZYW is 72. ZXW would be how much? This will also be 72 degree. From a arc, you can form any number of angles, inscribed angles, they will always be equal. Okay, any inscribed angle from a arc will always be equal, and that would be half of the central angle. So this angle, whatever I drew, this is also 72, and this angle is also 72. Find the value of each variable. So how much would be 5x degree? Yes, so 5x would be equal to 90. Why it is 90? Because this is a diameter, and diameter is 180 degree. Central angle is 180 degree. So inscribed angle is half of the central angle. So it is 90 degree. A inscribed angle on a diameter is always 90 degree. So that's how you can solve this question. In this question, they are asking 2c plus 6. How much would be c, for example? So yes, so c plus 2c plus 6. Okay, c plus 2c plus, sorry, minus 6. 2c minus 6 is how much? 180 degree. Why? Because opposite angles of a quadrilateral inscribed in a circle are supplementary. So then you can solve for C. Same here, 8x plus 10x, 18x is equal to 180 degree. So x is equal to 10. Okay, because 8x plus 10x would be supplementary.